Good afternoon. My name is Guilherme. I'm tutor here at the Honors College for Honors Statistics, and this is Friday, the 21st. And I'm also a freshman here at the Honors College. And today I'm going to be doing the Test 3 worksheet for the Honors students. And also I'll leave the PDF all together with the video. So the first question of the PDF is that X has a uniform distribution, right? So X has a uniform distribution, all right, from 0 to 10. And we gotta find the probability that X is between 2 and 5. So we know that because it's a uniform distribution, and I'm also be drawing to better explain this probability. So the first thing we're gonna do is draw sort of a graph, and we know that we have the bounds 0 here, and I would say that 10 is here, all right? And we have to find the value of x that is between 2, could be 2 and 5. All right. So what's the probability that x is in between 2 and 5? First thing we're gonna do is to calculate this probability. We can calculate this using this sort of as the base of our figure, and we're gonna find a height of it. So we know that for uniform distribution, if our base is this, let's say that our total width here is 10 minus 0, which is 10, all right? So we know that the height here will be always 1 divided by b minus a. B here, what is our b here? Our b here is 10. Our a here is 0. So this will be the same as 1 over 10, which is 0.1. So this will be our height, because when calculating for the uniform distribution, and you're going to find the probability of x between two other values between an interval within the distribution, you do it this way, all right? So the value of x is between the 2 and 5, and our height is this. So first thing I'm gonna do is ask, if we just had 5 and 2, what would be our b minus a? Do you agree that our b minus a would be the same as 5 minus 2, which equals 3? So when calculating the probability for this type of question, you gotta do your b minus a here times the height you have here, because this height will be the same for the entire graph that we have, the entire figure. So our b minus a here between 5 and 2, that is the question, is the same as 3. And we know that for a rectangle, right? We know that to calculate the area of a rectangle, we do the basis times the height of the rectangle, right? So the basis of the rectangle is 3. And the height of the rectangle or whatever is 0.1. So the rectangle represents 0.3, which is 3 times 0.1. So 0.3 will be our probability of x be found between 5 and 2. And 0.3 is the same as 30%, right? So we can definitely say that the probability of x being in between 5 and 2 for a uniform distribution that has as lower and upper bound 0 and 10, we can say that this probability equals 30%, which is the same as zero point 0.3. And that's the first question. And actually, the second question is very similar to the first one because we have the same bounds 0 and 10 for a uniform distribution, but here we have to calculate the probability of x being greater than 6. And this is uniform distribution again, right? So for uniform distribution, when you have this type of bounds and you gotta calculate this probability right here, we're going to do the same exact thing. So let's put the bounds here, 0. Let's put 0 here and 10 here. Now let's say that 6 is here. So we have to calculate the probability of x being here on this interval right here. And our height is pretty much the same as it was before. Our height here is 1 over 10, which is the same as 0.1. So we have another rectangle right here, right? Let's do the base. Time. The base is the number, the value that represents the right side of the rectangle with the interval in relation to the value that represents the left side of the rectangle. So we could say that the base is 10 minus 6, right? And 10 minus 6 is the same as 4. So having 4 here on the base and 0.1 the height, how we can calculate this probability? We can calculate this by saying that 4 times 0.1 equals the probability of x being greater than 6. And this is the same as 40% because 4 times 0.1 is the same as 0.4, which is 40%. The third question is actually a little bit more interesting. And I don't know if I'm going to be doing 5 questions or 10 maybe. But the third question is about exponential, right? It's about exponential distribution of exponential distribution with lambda equals 1. And we have to find a probability of x being greater than 0. And we know that with exponential distribution, right here, x being greater than 0 is the same as if we're going to find x being greater or equal to 0, right? And I think here the most important thing first is, of course, draw the exponential, right? And let's say that 2 is here because we don't have bounds or stuff to work with. So let's say that the probability of x being greater or equal than 2 is going to be exactly this. All here from 2 on under the curve. So when finding this sort of probability, we know that for a function, because this is the graph of a function, right? for the function f of x being greater than 0 for and when exponential distribution, because x is greater and not less. Because if it was less, let's say, if it was the function of x being less than 2, right? We would do 1 minus what I'm going to say. And you might ask yourself, why this 1? Because we know that the probability of x being greater than 2 is everything here. So the probability of x being less than 2 will be this. All right? So, and imagine that all of this area here equals 1, which is the same as 100% of the area. So, if x was less than 2, we would first have the 100%, right? The total, imagine the total area minus this, right? Because the total area is the red plus the purple. And we just want to know the red. So if we had red plus purple and we just want to know the red, we gotta do red plus purple minus the purple, right? So then we're going to be left with just the red if it was less than 2. But in the case here, right? In our case here, and I'm going to erase the red area. In our case here, it's f because this is function f. It's going to be f is greater than 2, right? So with x greater than 2, we don't need the 1 minus something. We gotta go straight to something. So f, and that's the thing, that's the catch for exponential distribution. So with f greater or equal to 2, we can do e, that's e. We can do e to the power of negative lambda times x. That's what you gotta do when you have exponential distribution and finding probability. If it's greater, go straight to e to the power of negative lambda times x. If it's less than something, you gotta do 1 minus this right here. But that's not the case. And we know that for here, we don't have we're not going to plug in the e number. So let's leave it like e. And we know that our lambda here is 1. And we need negative lambda. So let's do it negative 1. And we know that our x shall be greater than 2, right? So the only value of x we're considering here will be 2, be it greater or less. If it was less than 2, then we'll do 1 minus this, right? So negative 1 times 2, we could say that the function f of x greater than 2 is the same as e to the negative 2. And for this step right here, we can use the calculator. So I'm gonna use, and I like to use this calculator right here. I like to use, this one, right? So here on the calculator, I'm gonna click second here. I'm gonna click second. Then I'm gonna click right here because E is right here. So now I have E to the power of something. And our power here is -2. So and don't confuse the minus sign with the negative sign. So I'm gonna click negative and 2. So now I have E to the -2, which equals point. Let's approximate it for 4 decimal cases, right? So this is our result right here. Some amount of numbers. So approximating to 4 decimal numbers, I would say that this is the same as point. Yeah, don't forget the point. Point 1353. And also, it's important to be point because it cannot be greater than 1, because 1 is 100% chance, and it cannot be greater than 100% chance. So this equals to 0.1353, which is the same as 13%, 0.53. And that's our answer for the third question. So the fourth question is actually also very similar because it's the same. It's exponential distribution with lambda equals 1. And now we've got to find probability of, let me see if, if this is right. Yeah, we have to find probability of x being in between 1 and 6. And one thing that I would like to mention here is that imagine if our 1 was, let's say that this is the same as the probability of x being in between A and B, because this would be our bound, right? And since we want to find area here, and for those who already took Calc 1, we know that if we have to find area, especially with bounds, right? We've got integrals, right? And our upper bound here is B. Our lower bound here will be A. And what will be our function here for exponential? Our function here will be lambda E to the, yeah, to the negative of lambda x, I think, dx. Because integral represents area, and B is our upper bound, A is our lower bound, and that's our function right here. So we can also equal this, right? And you're going to see this step correlating with our task here. We can equal this to the same as E to the power of negative lambda times A minus E to the power of negative lambda times B. Yeah. And now I'm going to explain this because imagine that we want to find the probability of x being in between 6 and 1. So this right here would, I'm gonna draw it. So I think it will be easier for you to understand. Oh, let's make this more beautiful. All right. So this is, right? This is f of x, let's say. And imagine that our 1 is here Our 6 is here. And we're going to find the probability of x, the value of x, being in this between right here. So how are we going to find it more specifically? We know that this, right? That is what we did the exercise before. We know that this would represent, in our case right here, e to the power of negative lambda times 1, right? Because our lower bound is 1. And we know that this will represent the area greater than 1, right? Because if you separate it, you know that we've got that x is greater than 1. So imagine that we just got the x, the probability of x being greater than 1. Probability of x being greater than 1 would be all of this, right? Because 1 is right here, and the probability is everything greater than that. But that is not the question. We have an upper bound. Our upper bound here is 6. So you gotta find the probability of x being greater than 1, but less than 6 at the same time. So that's why we do this right here. Because this is x being greater than 1. This would be the same as x being greater than 6, right? So I'm gonna do this with the red pen, red marker. Probability of x being greater than 6 would be this in red, right? And this is still purple, just to remember. So we have the probability of x being greater than 1, that is everything that is purple, minus the probability of x being greater than 6, right? Because this difference between the purple and the red will be and will give us this interval right here. And this is what we want. In this case, we want the blue area. That's what we want. So that's why when you have an interval, when you have two bounds for exponential distribution, you gotta do it this way. You gotta do the area with the lower bound minus the area with the upper bound, greater than these bounds, right? The area greater than the lower bound minus the area greater than the upper bound, because this difference will give us exactly this interval right here. So working on that, we would say that we already have the area greater than the lower bound, e to the power of negative lambda times 1 minus e to the power of negative lambda times 6, which is our upper bound. So here we have, well, we also have the lambda is 1, right? So here we have negative 1 times 1, which is e to the power of negative 1 minus e to the power of negative 6. We have this right here. So now, what you gotta do, because we're leaving this like e, you gotta plug into your calculator. And I'm going to do the same way. We're gonna hit second, then e right here. So now we have the first e. Our first e is negative 1, close parenthesis. So we have e to the negative 1 minus sign, not this one this time, this one minus second e to the power of negative 6. And you don't need to close the parentheses, but you can if you want. So this gives us this right here. It gives us, approximating to 4 decimal cases, this probability right here gives us 0.3654 chance, which is the same as 36.54% of chance that x being in between 1 and 6 for our exponential distribution. That's question number 4. And for question number 5, that is the last question I'm gonna do today, because my tutoring hours already came to an end for this Friday. So for question number 5, also related to exponential distribution with lambda equals 1, we got the probability of x being less this time than 1.2. Remember, if x is greater, the area is to the right of that bound. If it's less, the area is to the left of that bound, right? So I'm gonna draw it again to make things easier. Imagine that our 1.2 is right here. If we were to calculate the probability of x being greater than 1.2, it would be this, greater than 1.2. But we don't want this, right? What we want is this, the black area. That's what we want. So how can I get this? That's what I explained before. If we have this as being greater and the net area, the total area, equals 1, which is 100%, we know that if we do this probability, if this probability is the same as 100% everything minus the purple area, if we know that the net area minus the purple area is the same as the black area, now what we're going to do is what we did before in the previous examples. We're going to do 1, right? We're going to do 1 minus e to the power of negative lambda times x, right? Because this is the purple area, the area to the right of the bound. And this is the total area minus the purple area. So for here, we have 1 minus e to the power, our lambda is still 1, so it's negative 1 times x, which is 1.2. And don't come up with any new values or stuff. Stick with the x it gives you, because this is the bound you're going to use. So that's what we got, which is the same as 1 minus e to the power of negative 1.2. And now, guess what? What you gotta do? You're gonna go in your calculator, because we're going to keep e as e. We're not going to transform it to any value, although it's possible. So in your calculator right here, first thing you gotta do, you gotta type in 1, right? And we have 1, which is the 100% of the area, minus, now let's do second again, e to the power of negative 1.2. So now we have 1 minus e to the power of negative 2, rounding to 4 decimal cases, gives us the result of 0.6988, which is the same as 69.88% of chance of probability that x, the black area, is less than 1.2. So that's the answer for the fifth question. I hope you all learned something and enjoy as well. And on my next tutoring hours, and I'm gonna be doing more exercises and continue through the worksheet that I'm going to. I think I can provide this with this video, and the topics will change because here we got exponential distribution. We're going to have hypothesis testing with two samples and not one. So that's me basically studying for the finals exam, and I hope you all enjoy. And I'll catch you on the next video.